Good morning, guys. Now let's know about the stress. What is stress? But before we begin this topic, firstly we know about the what is the mechanics. Okay, what is the mechanics? What is mechanics? Uh, I think we all know what is force. Okay, something which can be with the help of something we can something push or pull. Okay, that thing is known as the force. But force and their effect is also important for us. Okay, so then in mechanics, force 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 and their effect on the body. In mechanics, we deal with the force and their effect on the body. What is the force? We all know. And what is the effect of the force on the body? It is also known. We know that due to the force, any body going from one place to the other place, any body travels some distance, some displacement. Okay, so then effect of this force is displacement, displacement, velocity, acceleration, acceleration, and most important thing is deformation. Deformation. Then these all things, this all effect is done with the help of the force. Okay. Now know about something. What is the body's? Here three terms is important. First force, second is their effect, or third is the body. Okay, and we know about the force and their effect here. If you apply some force on the body, their effect is the effect of displacement, velocities, accelerations, and the deformation. But what about the body? Which type of body we apply the force? On which type of body we apply the force? Okay, then body. Body are classified in two categories, two ways. First is solid body, solid body, and the second is the fluid body. Second is fluid body. Okay, and most important thing know here is the solid body is also classified in two categories. We all know about the solid body. We all know about the solid body. What is solid body? Everything here. This blackboard is the solid body. This marker is the solid body. Okay. But this solid body also classified in two categories. First category is the rigid body, and second category is the deformable body. Rigid body, rigid body, and deformable body. Deformable body. Okay. And what is the rigid body and what is deformable body? We will know about it. But before that, we know about the. We will know the fluid body. What is fluid body? Fluid body. Anything which can flow, anything which can flow is known as the fluid body. What is the examples? If we know about the examples, then air, water, blood, etc. These all are the examples of the fluid body, because we know air is also flowing, air is flowing, water is flowing, and blood is flowing in our bodies. Okay, now know about the rigid body and the deformable body. Okay, but before this, let's do an experiment. What is the experiment? See here. See. Suppose we have a body. Suppose we have a body. This is the body. Okay. and this body is made by the different particles, different n numbers of particles available in this body. Okay. Now let's assume, let's take two particles A and B. A and B. Okay, and they are situated at length L. They are situated at length L. Anything L is the 4 centimeter, 5 centimeter, anything. Not the 5 centimeter. These are the nanometers, microns. Okay, they are very small units. They are very small distance. Okay, that means they are the A and B are in the nanometers, angstrom, and the micron. Okay, now see, if we apply different type of coplanar forces, on these bodies, we all know what are the coplanar forces. The forces which are applied on the same plane is known as the coplanar forces. They are applied on this body, this blackboard. So these are the coplanar forces. Okay. After applying these forces, if what happened? If this distance A and B, the distance between the A and B is going to be changed like LS. Is going to be changed LS after applying. Now see, if we apply force A and B, if we apply forces on this body, then if this length L is same as the previous one, if that means, what is that mean? If L is equal to L, that means this length is not changed. They are same. Okay. Then this type of body is known as the rigid body. If L is not equal to L, that is what is meant? That means if we consider this length is the 2 centimeter or 2 micron, 2 nanometer, and after applying the force, this body and this length becomes 2.5 centimeter, for example, and this is 2 centimeter. That means this length is changed 2 to 2.5. Okay, that means they are displaced from their original position. These two particles are displaced from their original position. Then this type of body is known as a deformable body. That means their shape, size are changed after applying this coplanar forces. Okay, so we know about what is the rigid body and deformable body, I think. Now, after due to this deformable body, we know some terms. We will know about some terms. The terms is the deformation. Deformation. That means if the relative positions between two molecules, two particles are changed after applying the forces. Then this phenomena is known as the deformation. Okay. Now see. That means we know that if total change in length, the deformation, if we represent in mathematic term, then deformation is the total change in length. Total change in length. That means final length. That means after applying the force, the molecules between them is going to be changed or not changed. In case of the rigid body, they are not changed, but in case of the deformable, they are changed. Okay, then the final length minus initial length. See. One minute. This is the total change in length, or shortly called as the, we call the total change in length, or shortly we call as the deformation. Shortly we call the deformation. Okay. And due to this deformation in the body, a new term is generated, is known as the strain. What is strain? And due to this strain, a scientist gives a law known as the Hooke's law, is uh, tell about the is told about the stress. Okay, so due to deformation, first due to deformation we got strain, and due to the strain we got stress. Okay, so always strain comes first, then the stress. Okay, and now see what is the stress. But before this, we go about the some. We will know about some assumptions. Because why we take assumption? Why we take assumption? Because in engineering, if we talk about the engineering, everything is going with the help of the assumptions. Okay, everything is going with the help of assumption, because without assumption we can't study everything. Okay, so we know about some assumption. First assumption, because in previous lecture I told you that we always sacrifice some calculations. Engineers are always sacrifice some calculation, but in science background students, they are not they are not sacrifice some calculation. Okay, because in engineering there are a lot of calculations available here. Okay, if we can't do any, if we can't take any assumption, then our study is going to be very tough. Okay, and calculations portion are also tough, so we take some assumptions. So what is the assumption? Assumption first. We take and bar. We take and bar. We take a bar. We take a bar. Give me a moment, guys. We take a bar. Which type of bar it is? This is the prismatic. This is the prismatic bar. This is prismatic bar. Okay. We all know what is prismatic bar. Let's know about it. See here. This is the 2D figure that we see from the front view of this bar. If we take this 3D structure, then this is the bar. This is the 3D diagram of this bar. Okay. See, uh, what is prismatic? What is prismatic? If we talk about this cross section areas of this bar, what is the cross section area of this bar? Cross section area of this bar is this square or rectangle. Okay, if we cut from here, then we got this area. If we cut from here in transverse direction, then we got the area like this. This area is the cross section area. We must know the difference between the cross section area, total surface area, and surface area. This is important for mechanical engineering. Okay. So this is the cross section area. What is the cross section area? This is square. If we talk about this is the A and this is B, then A. What is the cross section area? Cross section area is A and A. So in prismatic bar, in the whole bar, this cross section area is the same. We can't take take the bar like this. That means at every position, our cross section area is going to be changed or different. Okay. So this is the first assumption, that in every cross section area of this bar is same. We know in this whole bar there are infinite number of the cross section area. There are infinite number of the cross section area. Okay. So they are the same. They are the same cross section area. Okay. This is our first assumption. I think we all know what is the cross section area or what is the prismatic bar. Okay. Now see. Now, this is the assumption we must know, and after that, let's talk about the stress. What is the stress? It is nothing. It is the it is the internal resistive resistive force force develop inside the body inside the body that means prismatic bar, due to externally applied load. See what is it means. See this marker or this chalk holder. See, this is the bar. Suppose this is the bar, and we apply some force, applied external load. Then what is? Due to this applied external load, the deformation occurs in the body. Because in real life, not every body is the rigid body. Every body is the deformable body. Okay. So due to this applied load, this body is going to be deformed. But every body has inherent property that everybody is trying to oppose their change in shape. Okay, they are trying to oppose. That means they are not going to be deformed due to applied force. So how can we say that this body is not going to be deformed? Due to this term, internal resistive force. Something, if we apply some external load, then this body is made by the different particles. We all know every body is made by the different small particles. Okay, so every small particles apply a load just in opposite direction at the same intensity of the external applied load, so that this body is not going to deform. If internal resistive force is also greater than this applied force, then also going to be this body is going to be deformed. And this if this external applied load is more than the internal resistive force, then this body is also going to be deformed. So for not deformation of the body, this internal resistive force equal to the external applied load. External applied load. Okay. Now see this is the bar. And at one end this bar is going to be fixed like this. We fixed here. Okay, so that this bar is not going to be down. Okay, not going to be down. So, and now apply a external load in this direction. This body has the circular cross section area. This body has the circular cross section. Like this body is like this. They have this cross section area is the circular. At every point, this cross section area is the circular. Okay, so this is the prismatic bar. One type of example of prismatic bar. Prismatic bar. Let's see what happened. If we take this cross section area like this, like this. See, apply force P here. We apply force external applied load here. So this body is made by the different particles. So let's know about some different particles. Okay, we applied some different particles. Okay, now see what happened. This point B below, this is the A point, this is B point, this is C point, D, E, F. So this is the end points available here. Now, due to this applied load, this body, this point is trying to oppose the change or deformation. Okay, so represented F1. This point also represent F2. This is also opposing F3. Similarly here Fn. Okay. Every point is trying to oppose the change in the dimension of this body due to the external applied load, so that this body is not going to be deformed. Okay. Now see. See what happened here. F1. What is F1? Internal resistive force or intensity at A point. F2 internal resistive force or intensity at B point. Similarly, Fn internal resistive force at N point. Okay. F1, F2, F3 all are the internal resistive force at the A point, B point, C point, and the N points. There are N points. There are N lot of points available here. We just take here this thing. Okay. So every point trying to oppose this force P. Now see. Okay. Now what is the see here? Let me do this. What is the intensity of this force F1, F2, and F3? What is the force of the F1, F2, and F3? See. Here we know this P, and this A, this P and this A is known quantity. We know this the cross section area is A, and this is the applied force P. This is the 50, 60, 70 Newton we all apply, and this is the cross section area pi by 4 d square. We all know what is the cross section area of the circle. Okay, but this F1, F2, and F3, these all the unknown quantity for us. These all are the unknown quantity for us. Okay, so this F1, F2, F3 we have to find out. What is this internal resistive force or the stress? We all know these internal resistive forces is also known as the stress. In the definition, I wrote that the stress. This is the internal resistive force. The first line. Okay, I wrote in the first line. Okay, so we have to find this F1, F2. Okay, so here we take one more assumption. Here we take one more assumption. What is the assumption? That this all the intensities F1, F2, F3, F4. These all intensities are same. That means F1 is equals to F2, this is equals to F3, this is equals to F4, and then up to F. Okay. This all are the F1, F2, all intensities are same. So according to the mathematics, we all know if all the intensities are same, then we can write n types of F, n types of F1. F1 we can write F1, F2, F3, anything, n types of F1, and this is equal to F. This is equal to F. We can write it. All forces we can relate. This F is equivalent to the n into F1. This F is equivalent to the n into F1. Okay. So what is the F1? F1 is equal to F by n. F1 is equal to F by n. Now, one most interesting thing, see here. Now see one interesting thing. What is? We all know about the circle. We must know. And in mathematics, we know that the circle. There are three types of circle. First is the real circle. First is the real circle. First is the real circle. Second is the imaginary circle. Second is imaginary circle. Imaginary circle. Imaginary circle. We all know the equation of this circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. X square plus y square plus 2gx plus 2fy plus c is equals to 0. And the radius is under root g square plus f square minus c. We all know about it. Okay. See, this radius. This radius defines this type of circles. This radius is going to define this type of circle. What is the real circle? What is the imaginary circle? If here we see this is in under root, and we all know in under root this is the root function. In class 11 in the second chapter, I think in second chapter in NCERT second chapter, there are the relation and function, and we all know that in under root, if something is going to be negative, then this is not defined. Then this is not defined. This is another topic. This is called as the complex number. Okay. So here, if this g square plus f square minus c is going to be positive, then this type of circle is the real circle. Okay. And if this whole term g square plus f square minus c is going to be negative, then this type of circle is going to be imaginary circle. But see, there is one more type of circle. I think we know that third is the point circle. Point circle. That means this point. I think this point. This point is also a circle. A circle. How? This r under root g square plus f square minus c. If this is going to be 0, then this is also the radius now. If r is going to be 0, then this is also the radius now. So this is, if r is the 0, then this is the circle, point circle. So why I am told this thing, because we know there are in this cross section area there are a lot of points. There are n number of points. There are n number of points, and this all points is going to be made a cross section area of this whole circle. That means this point, this point, this point, this point, this point, this point, this point. These all points is going to make a whole area. That means we can say that this n is equal to area of this cross section area. Okay. So I can put here f1 is equal to f by n. F by n. F by n. Okay. I think we all know what is the f1 is equal to f by n. This f1, we can see f2 is also equal to f by n, because f1 is equal to f2 is equal to f3 is equal to fn. So f2 is equal to f by n, f3 is equal to f by n. Okay. So these all are the internal logistic forces or stress. Stress. And this stress is same at every cross section area. So we can in strength of material subjects, this F1, F2, this stress is represented in this by sigma. This stress is represented by the sigma. So we can write sigma is equals to F by A. And this F is going to be equal to the P. This F, because we know if we apply, sorry, we see here. This is the cross section area, and we apply force P. And this F1 totally, if we calculate all the forces F, then this P and F is going to be equal, so that this bar is not going to be deformed. So we can write F is equal to P. I think we mention equation for the for not going to be deformed is that the internal resistive force is going to be same as the this all the internal resistive forces, and all the internal resistive forces is going to be equal to the F. Okay, so we can put sigma is equal to F by A and F is equal to P by A. This is the stress, and this stress is same in all the cross section area. But we know one thing is that this stress is the point function. This stress is the point function. That means at every point this stress is going to be changes. Okay, but in different scenario, in the next chapter, in the twisting moment, in the bending moment, we will know how this stress is going to be changed at point to point. Okay, okay, so but here we see that this stress is the same all this in all this cross section area. So this sigma is represented in terms of the sigma average. This sigma is represented in the terms of the sigma average. So we can say that this stress, the formula of this stress, the formula of this stress or the internal resistive force sigma average is equals to P by A. P by A. See, this formula is same. This formula is same as the pressure. This formula is same as the pressure. But pressure is the external phenomena, but this stress is the internal phenomena in the body. Pressure, we apply pressure always on the external surface, perpendicular to this external surface. Always force apply, pressure apply on the perpendicular direction to the external surface. But here, this stress is the internal phenomena. Okay, so we must differentiate. We must know what is the difference between the stress and the pressure. But here, the unit of this stress is same as the pressure. What is the force unit of the force? Newton, and area meter square or mm square or something other. Okay, so if Newton per meter square, we all know what is this. 1 Newton meter square is known as the 1 Pascal. 1 Pascal. We all know. Okay. See here. If 1 Newton mm square is equals to 1 megapascal, and 1 kilonewton per mm square is equals to 1 megapascal. These all are the units we must know. In questions, in examination, okay, this formula, this value is put direct. Not going to change the Newton per meter square, not we are going to change the Newton per mm square. Okay, so that we can save our time. Okay, so this is the stress. Now in the next class, we will know about the strain. What is the strain and some numericals about the stresses. Okay, thank you class.